In this video, we're going to learn how to solve an exponential equation. So in order to solve an exponential equation, you first want to look for a common base between each side of your equation. What I mean by finding a common base is 16 can also be written as 2 to the fourth power, and 8 could be written as 2 to the third power. And if you rewrite them this way, you'll see that 2 is its exponential base that it shares in common. So what I can do is go back to the original equation, and I can rewrite 16 as 2 to the fourth, then raised to the 3x, and 8 can be rewritten as 2 to the third. When you raise 2 to the fourth to the 3x power, you would multiply its exponents, giving you 2 to the 12x is equal to 2 to the third. And now that they share a common base, we can also say that their exponents are also equal, giving us 12x is equal to 3. And from here, we can finish solving. So divide by 12, and you'll get 3 over 12, which simplifies to 1/4. This is a really good fraction answer to get. Now, next up, they could both have an x on them. Maybe it's not just the one side has an x term, but both sides could have an x, but you're still looking for that common base that they could share. Here, 9 can be written as 3 squared, and 27 can be written as 3 cubed, causing that common base of 3. So I go back to my equation, rewrite 9 as 3 squared to the x plus 2 is equal to 3 cubed to the 2x. Multiply those exponents out, give me 3 to the 2x plus 4 equals 3 to the 6x. And now that they have a common base, just like before, I can set those powers equal to each other. Give me 2x plus 4 is equal to 6x. I can subtract 2x, give me 4 is equal to 4x, and x is just equal to 1. Now, for the next example, I see that 15 and 285 do not share a common base and cannot. So I need to think of another way to solve it. Now, one way I can go about this is by rewriting this in logarithmic form. Meaning the exponents, 3x, can equal a logarithm, since logs equal exponents. Base 15, the same as the exponential base of 285. Now, from here, I can divide each side by 3, which is just multiplying by a third, giving me x is equal to 1/3 log base 15 of 285. Now, this might not be an obvious numerical solution for you. What does this equal? Since 285 is not a power of 15. But in order to see what the answer is, I'll use the change of base formula, which would be 1/3 times log of 285 over log of 15 to see what decimal approximation this would be. So I'll take a calculator. And I'll plug in 1/3 times log of 285 divided by log of 15. So this is approximately 0.69, and what's a 10,000ths with this 4 decimal places? So 6958. About that much that x would equal. This is an approximation while this is an exact answer. So when checking your solution, if you were to plug this back in, just know that this will be approximately 285, not exactly 285, since I rounded. Now, another method for solving these types of exponential equations where you can't find a common base is to just take the log of each side of the equation. The reason why this works so well is now, since that variable's in the exponents, if it's inside of a log, there's that log rule that allows you to pull the exponent out in front of the log. So this will give me 3x minus 4 times log of 2 equals log of 5. And then I can continue to solve. I can divide each side by log 2. Giving me log 5 divided by log 2. I can add 4. So 3x equals log 5 over log 2 plus 4. And then divide each side by 3. Giving me x is equal to log 5 over 3 log 2, because I divided by 3, so that 3 is in the denominator, plus 4/3. Now, approximately how much would that be? Well, let's just plug that in to find out. So we have log 5 divided by 3 log 2, 3 log 2, and then plus 4/3, which is approximately 2.1073. About 2-ish would be the solution here. Now, for the last example, we have a word problem. We say your lumber company has 1,200,000 trees. You plan to harvest 7% of the trees each year. So how many years will it take to harvest half of those trees? So we have a rate that's going down each year. So we can set up an exponential function. So a of t is equal to p times 1 plus r to the t. In this case, t will be how many years have passed. A of t will be the number of trees left after t years. P will be the starting number of trees. And then R is your rate, which you cut down the trees. So plugging everything in, the number of trees I would have after t years, I want half of the trees, so half of 1,200,000 would be 600,000. The starting number of trees is 1,200,000. Then 1 plus your rates, which is a negative percentage, so negative 0.07, and then raised to the t, which is what I'm looking for. How long will it take? So simplifying the statements, I can write this as 600,000 equals 1,200,000 times 0.93, which is 1 plus negative 0.07 to the t. And now I want to solve this equation to find how much time is going to pass for me to get rid of half the trees. So first I'll divide each side by 1,200,000. And 600,000 over that should be 1/2, so I'll put 0.5 equals 0.93 to the t. And then I have to solve this equation, so I'll just take the log of each side of the equation. So log of 0.5 is equal to log of 0.93 to the t. I can bring that t out in front of that logarithm, so log of 0.5 is equal to t times log of 0.93. I can divide by 0.93, give me t is equal to log of 0.5 over log of 0.93, which would be approximately a certain amount of years. So log of 0.5 divided by log of 0.93, which would be approximately 9.55 years. About 9.5 years it would take to get rid of half of those trees if we follow that same rate each year. And that is how you solve an exponential equation.